Hello, and back by popular demand is the Select Practice Problem Help. So I apologize for not doing those for the last few lessons of Unit 2. We're back on it here, so we're going to look at problems 4 and 7, and this is Unit 3, Lesson 1. Unit 3, Lesson 1. Okay, so let's look at problem 4. So problems 1 through 4 are kind of all sort of the same thing. The problems 1 and 2 deal with adding the functions. I picked one where you're subtracting because it presents you with a slightly trickier combining like term situation. Not much. If you were paying attention while we were doing the combining polynomials, when we were adding and subtracting and multiplying and dividing them and all that, you would have noticed that this is a lot like that. Right, a lot like that, and that's why we did it. So let's do this. All right, so what they're asking us to do is they're saying for each pair of functions below, find f minus g of x, state the domain and range of that function. Okay, so when we do f minus g of x, that basically means you're taking f of x and you're subtracting g of x from it, right? It's that simple. So we're going to just basically pick these functions up and drop them kind of in their places. So this is what I'm going to do, and I'm going to do this just to kind of prove a point. Is I'm going to put two sets of parentheses here. We're going to put f of x right here. We're going to put g of x right here. Okay, I'm going to put my minus sign, and so this mirrors exactly what we have here, right? And so now all I got to do is just kind of pick this stuff up and move it in. So if I could cut and paste it, I would cut and paste it, and then, you know, we could try that. That'd be kind of wild, right? If I did that. I don't have a snipping tool on this, but you take this and you go, all right, so that's going to give me minus x squared plus 6, so that's my f of x. So I literally just copied it down. And I'm going to do the same thing with g of x over here. I'm going to go 2x squared plus 3x minus 5. All right, so that's the that's the easier of the two parts, but just to be able to set it up like that and get it like that is good. And I'm gonna move this minus sign kind of up in the middle where it belongs. All right, and so now the next thing I'm going to do is I'm going to drop the parentheses so I can start moving things around. So the first set's really easy to drop because there's nothing going on with it. The second step, we have to be careful. Remember, this minus sign, you can think of it two different ways. You can think of it as we're going to negate everything that's in here. So if there's a negative, you make it positive. The way I like to think of it is make everything the opposite. So if it's positive in here, it becomes negative. If it's negative in here, it becomes positive. And I think that's a slightly easier way. I'm going to show that we're doing this. You can think of it as multiplying everything by -1, 2, if that works for you. Whatever it takes, just try to get it right. So you're going to get negative 2x squared, because that's the opposite of 2x squared. You have negative 3x, because that's the opposite of positive 3x. And then you have negative 5 already, so the opposite of that's going to be positive 5. And so with this, right, now I have everything written down. It's just a matter of collecting things. So here are my x squared terms, all right? So we've got -1 and -2, so that together gives you negative 3x squared, all right? And then we have negative 3x, and this is the only term that has just an x with it. And then we got 5 and 6, right? We got these two, so we're going to go plus 11, right? And that is combining like terms. This is something we've done. We should be pretty familiar with it, all right? Minus 3x plus 11. And so the domain of all of these pretty much is for adding and subtracting, and usually multiplying, not always, but usually you're almost always going to have all real numbers. And so remember, when we write our set notation, we go D is equal to, put your brackets and you say for all x, right? And then you would say all real numbers, all right? That's how we do it, right? You put x to show that domain is x, right? For range, we're going to start it the same way, right? We have our bracket. You put y, you put your flat bracket. Now we're going to figure out where this thing is, right? So we've got negative 3x squared minus 3x plus 11. So we'll go here, and we'll go Lx is equal to negative 3x squared minus 3x plus 11. All right, I'm going to check this and make sure I did it right. Yep, that's it, right? Negative minus 3x plus 11. All right, and you can see that, oh, wow, this thing's high, right? But so it gets up to this point right here, and then up here it looks like it goes down, right, from here. And then everything's below this. So to me, that looks like 11 3/4. Let's see what it says here. Yeah, it's 11.75. So let's put that in, right? So let's go to here. We would say y, and so y is going to be less than everything. That, so we'll go y less than. All right, and then you don't want to write 11 3/4. So you could either do it 11.75. So one way you could do it, or you could figure out how to write this in an improper fraction, right? Well, that would be 44 plus 3, so 47 fourths would be one way you could write it. So pretty much that's what you're doing, right? Just trying to get that sorted out. And then on this one, all right, so number 7 now, you're gonna basically add these and subtract both of them, but you're gonna do them at a certain point. And so we don't have functions to actually physically combine, but what we can do is we can find f of 0 and g of 0. So I'm distributing this, right? And I can find f of negative 1. I can subtract g of negative 1. So I can these I can do, right? And so it's a matter of finding those values, putting them in, and then doing the operation. So f of 0 is simply find the function f, put 0 in for x, so that's right here, right? So these are where we're putting our functions in for this one. And then just see what the value of the function is. So at 0, the value of f is 2, because that's the point 0, 2, right? Input is right there, and then your output is right there. Okay, and then do the same thing for g. So you come down here, and you have the point 0, negative 1. Here's your input, here's your output. So you have 2 plus negative 1. And then you just combine it, and you get 1. So that is that's the answer to this first one. And the second one, we're going to do the same thing, except now we're going over to negative 1. And we're subtracting this time. So we go right here, right? And this is the value at negative 1 of f of x is 0. So that's easy. So we go 0 minus. And now the value at negative 1 for g, right? It's, you go all the way down here, and it looks like it crosses right here. And they give us nice numbers on these. So we got 1, 2, 3, 4. So this is negative 4. So you put in negative 4. And then you'll see that you have a, we're not adding, we're subtracting. So basically, whenever you think of subtracting, think of the distance between two numbers, right? And if you thought about it that way, you'd be like, well, between this number and this number, it's 4. Well, it's the same thing, because you have this double negative happening here. So 0 plus 4 is 4. So if you can think of difference as distance, I think sometimes that's easy when you're dealing with the negative numbers, and it helps keep you kind of honest. So hope that helps. Have fun with these, and we'll talk to you later.